In this video series, you're going to learn pygame while building a customizable Brickout game. Today you'll learn a lot more about surfaces, pygame's drawing canvas. In the last video, we built this game composed of a jittery square trying to escape the window, and we gave the player the ability to pull it back in with a click. Today we'll swap that for a circle that bounces off the edges of the window, like the ball in Brickout. I'll link video 1 here if you need to catch up. This is Brickout 2.0, or it will be when we're done. I'm going to remove the code that made our square appear jittery, leaving us with code that adds 2 to the x and y variables and then blits the background and the square. I'm also going to change the screen and background size to be 600 by 400, so the action is a little easier to see on video. You can see the changes result in a square smoothly moving diagonally downward to the edge of the screen, and then right off. And maybe that's the first thing we should talk about, why that square is moving down. I'm adding 2 to the x-coordinate, and the square is moving to the right. That makes sense. But why does adding 2 to the y-coordinate move the square down? In the pygame coordinate system, y increases as we move down. The top left coordinate of the surface is 0, 0, and the bottom right is height, width. So we add to y to move down and subtract to move up. Let's bounce the square. How do we do that behind the scenes? When the square touches an edge, we want it to, first, not move beyond the edge, and second, change direction so that it's moving away from the edge. We will add 2 new variables, one for the change in x each time through the loop, and one for the change in y. We'll call them dx and dy of type integer. And I'm going to give them initial values of 5 rather than 2, just to make our square appear to move faster. So instead of adding 2 to x and y each time through the loop, I'll add dx to x and dy to y. Storing the change in variables will make it easier to change direction and speed while the program is running. These are often called velocity, how much position changes each frame. Now, how do we know if the square has hit the edge of the screen? Remember how blitting works. We're blitting the square to an xy coordinate, which is the upper left of the square. If that coordinate is off the screen, then the square will appear off the screen, or partially off the screen. So we check that coordinate against the edges of the screen. The surface class has methods, getWidth and getHeight, which we can use to get the width and height of any surface, including the screen. I know, we already know it, we just changed it in fact, but that's exactly the point. I want to be able to make size adjustments without breaking the rest of my code, so I'll always ask a surface what size it is, rather than relying on a literal value, or even a constant. After I've increased x and y by dx and dy, I'll do some boundary checking. If x is less than or equal to 0, that means the square is heading off the left side of the screen, so I'll reverse its direction by multiplying dx by -1, and I'll also set x to 0 exactly, so it makes what looks like hard contact with the screen. I'll do the same for y. If y is less than or equal to 0, y equals 0, dy times equals -1. And should we try the same for the right and bottom? I'll add elifs to each if. Elif x greater than or equal to screen.getWidth, x equals screen.getWidth, dx times equals -1. And elif y greater than or equal to screen.getHeight, y equals screen.getHeight, dy times equals -1. Let's run that. And it's moving down and to the right, and right off the screen, and it's coming back. And you might notice that we're fine at the left and top, but the bottom and right allow the square to leave the screen entirely before it comes back. Any idea what went wrong? Pause the video and see if you can figure it out before we fix it. I dropped a hint before. When we blit, we're passing in the upper left coordinate of the surface. When we check if x is greater than the width of the screen, we're checking if the left side of the square is greater than the width of the screen. We need to check if the right side of the square is greater than the width of the screen. So that would look like x plus square.getWidth greater than or equal to screen.getWidth. And for y, y plus square.getHeight greater than or equal to screen.getHeight. And when we adjust the coordinate inside the elif, we should subtract the width or height of the square accordingly. X, the coordinate of the left side of the square, plus the width of the square gives us the right side of the square, and y, the coordinate of the top of the square, plus the height of the square gives us the bottom of the square. And with that change, we have a square bouncing in the window. So we've learned that surface objects have a width and a height, and we've seen how to use those properties to check that one surface stays contained within another. Now let's learn how to make our square into a circle. This is a list of drawing commands that we can use to draw on a surface, and you can see there's a circle drawing command. Seeing how circle works should give you a general idea of how they all work, and then you can read through the page and experiment with the rest of them yourself. I do have a video on the drawing commands if you want more guidance, which I'll link here. When we are setting up our square surface, instead of filling it, we'll use pygame.draw.circle. With this command, I pass the surface to draw on as the first parameter, so that will be my square. The next parameter is color. We can keep that white for now with 255, 255, 255. The center argument will be the coordinate of the center of the circle. That will be the center of the square, so I'll put square.getWidth, flooring division 2, square.getHeight, flooring division 2. I'm using integer division here, so the center lands exactly on a pixel, although Pygame will accept floats as well. I know I'm setting the square to 50/50 right above this code, but I want to write code that's resilient to changes, so I'm going to ask the square surface for its width and height. And then for radius, I want that to be half the width of the square, so I'll pass in square.getWidth, flooring division 2 again. And when I run that, I now have a circle bouncing around in the window. Pretty cool, right? It is cool, but I'm going to make a change to my program that makes it a little less cool. I'm going to give the background a color. And I'll just generate a random color by passing in a tuple made up of random.randint 0,255 calls. And I'll run the program. And now we can see that the circle is really a circle hiding inside a square. We can see the black edges of the square around our circle. A surface is always rectangular. Even if it looks like a circle, the underlying pixel grid is still a rectangle, so we can't change the shape of the surface to solve this. But what we can do is make parts of the surface transparent, so it looks like the surface has a shape when we draw it against a background. There are actually several different ways to handle transparency in Pygame. For this situation, where we have two colors and we'd like one of them to be transparent, the easiest solution is to set a color key for the surface. The color we set as the color key specifies which pixels will not get copied to the destination surface when the surface gets blitted. We would like the black, the background of our square surface, not to be copied. So after I create the square, either before or after drawing the circle, I'll type square.setColorKey, and then I'll pass in black, 0, 0, 0. And I run it, and that's it. The black parts aren't copied over to the screen when it blits. So no matter what the background looks like, I'll see the background through any black pixels in the square. Let's see that by loading in an image for the background. Find an image that is around the size of our background, 600 by 400 pixels, or change the size of the window to accommodate your image. If you've written the code generally, as I have, you shouldn't get into any trouble with the circle bouncing in weird places. Now drop the image in the same folder as your program, and make sure you know the exact name of the file, including the extension. Pygame can usually load in images of type JPEG, PNG, and GIF. In your program, instead of creating the background using the surface constructor, write background equals pygame.image.load, and then pass in your file name in quotes, including the extension. Mine is called poolleaves.jpg. When we create a surface this way, loading from a file rather than using the surface constructor, we should also send it the convert message. The convert message will return a new surface that has the same pixel format as the screen, which will make blitting quicker. I'll type background equals background.convert, or you can also do this in one step, adding .convert immediately after we load. So now we have a ball that bounces around our screen, and we can still change its location by clicking. In the next video, we'll learn more about keyboard and mouse events and using events to control screen elements. Until then, you guessed it, I have some homework for you. Pick what interests you from the following ideas, or do them all for maximum benefit. Now that you've learned about boundary checking, write this game so it starts the ball in a random location on the screen. Make sure the ball is fully within the screen's rectangle when you drop it in. Randomly change the ball's color on a click, rather than moving the ball to a new location. To get used to the dx and dy variables, Play with the speed. Try changing one and not the other and see how it changes the program. Draw features on the ball using the pygame draw commands. See if you can punch holes out of the ball by drawing with the transparent color. See if you can load in a ball image with a solid background color and set that to the color key, and then bounce your new ball around the window. If you get stuck or want to share your successes, drop a comment below. I look forward to seeing you in the next video. And as always, have fun and keep coding.